Yeah, so this is a question from GATE 2018. The question is a function f of ABC defined by three Boolean variables a, b and c when expressed as sum of product is given by f equal to, so we have a expression of f as sum of products, and where a bar, b bar and c bar are the complements of respective variables. The product of sums POS form of the function is, so given we have the SOP form, which is f equal to a bar, b bar, c bar plus a bar, b, c bar plus a, b bar, c bar. Okay, we need to find what is its POS form, that is product of sum. So how to find that? So for that, here we know f is a function of three variables ABC. So the possible min terms are a, b, c, a bar, b bar, c bar, then a bar, b bar, c, a bar, b, c bar, then a bar, b, c, then a, b bar, c bar, a, b bar, c, a, b, c bar, and a, b, c. So these are the possible cases, right? Possible cases of minterms. Okay, with ABC. Now here, according to equation, f is function of a bar, b bar, c bar. So it's a function of a bar, b bar, c bar, then a bar, b, c bar. So a bar, b, c bar, and a, b bar, c bar, a, b bar, c bar, right? So which means f is actually equal to 1 for these terms, sorry, right? And for all other terms, the value when the term is a bar, b bar, c, then the value is 0, right? So that's what actually this f means. And for SOP, what we'll do, we will just sum these terms, right? We'll just add these terms and we'll get the SOP, which is shown here. Okay, now for what to do for POS? So POS is actually can be written by taking the term corresponding to zeros, okay, and multiplying that. So how to find that? For that, we need to take the terms corresponding to 0 and write this term, okay, write these terms as is written as sum of its conjugates. That is, we will write these terms as sum of this conjugate. So what is the conjugate of a bar? It is a, plus the term corresponding to b bar is conjugate of b bar is b, plus conjugate of c is c bar, right? Then similarly here, for this term it is conjugate of a bar is a, plus conjugate of b is b bar, plus conjugate of c is c bar, right? Likewise here, the conjugate of a is a bar, plus conjugate of b bar is b, plus conjugate of c is c bar, and so on. So here a bar plus b bar plus c, and here it is a bar plus b bar plus c bar. Okay, so what is POS? POS is actually we need to multiply these sums, right? So POS of f is multiplication of this term. So a plus b plus c bar, first term, that into a plus b bar plus c bar into a bar plus b plus c bar into a bar plus b bar plus c into a bar plus b bar plus c bar. Okay, so if you carefully see here, the answer is C, a plus b plus c bar into a plus b bar plus c bar plus a bar plus b plus c bar, and into a bar plus b bar plus c and a bar plus b bar plus c bar. So answer is C. Yeah, so this is another question from GATE 2018. The question is, a 4 variable Boolean function is realized using 4:1 multiplexers as shown in figure. The minimized expression of f of u v w x is, so we have two multiplexers. Okay, so we need to find what is f. So first we will find what is the output here. So I'll call this as f1. Okay, so what is output here? So if you carefully see, the I0 and I3 is connected to ground, right? So the input here is 0, while I1 and I2 is connected to VCC. VCC corresponds to 1, right? The value 1. Okay, 5 volt or something. So what happens? What is f1? F1 will be equal to 0 when the input taken is I0, that is when u and v is corresponding to 0. So f1 will be equal to 0 when u and v is 0. Okay, while f1 will be 1 when input is connected to I1 or I2, that is when corresponding u and v is 0, 1 or 1, 0, right? Either it is 0, 1 or 1, 0, it corresponds to the input I1 and I2. So what is f1? F1 corresponds to I1 into u bar v bar. So I'll write here. So I can write f1 equal to, so first term when u and v is 0, 0, the output is I0, that is 0, plus 1 into when u and v is 1 0 1, right? So that is u bar v, then output is I1, that is 1. Then when u and v is 1 0, that is u v bar, the output is I2, which is 1, plus when u v is 1 1, that is u into v, then output is 0, which means f1 is equal to u bar v plus u v bar. Okay, so that is the value here coming, which is f1, right? Now here in second mux, if you see, the input to I0 and I1 is f1, and corresponding to I2 and I3 is 0, right? So what is f here? So f I can write as when the select lines are w and x. Okay, so if you carefully see here, when w and x is either 0 0 or 0 1, this corresponding to input I0 and I1, which corresponds to f1 and f1, right? And the other term, that is when it is 1 0 or 1 1, the input is I2 I3, which corresponds to 0, right? So what is f? F equal to f1 into w bar x bar plus f1 into w bar x plus the remaining terms are 0, right? 0 into w x bar plus 0 into w x. So this is like, so I'll take f1 outside, it will be like f1 into w bar x bar plus w bar x, or I can take w bar also, right? So f1 into w bar into x bar plus x, which is 1, right? So this term is 1, so f1 into w bar is the answer. And what is f1? So I know f1 is from here, f1 is u1 bar v plus uv bar, that into w bar. So this is the output f. Okay, so from the option is, yeah. So this is another question from GATE 2018. The question is, the logic gates shown in the digital circuit below use strong pull down nMOS transistors for low logic levels at the outputs. When the pull downs are off, high value resistors set the output logic levels to high, that is the pull ups are weak. Note that some nodes are intentionally shorted to implement wired logic. Such shorted nodes will be high only if the outputs of all the gates whose outputs are shorted are high. So that according to question, so here we have some gates output, like for example the output of this NOT and output of this AND is connected together, and similarly here the output of this XOR and output of this NOT is connected together. And what the question says, so if the output of two gates, for example the output of this NOT and output of this AND is connected, right? So this output, okay, this will be high only if this is high and output of NOT is high and output of AND is high. So if both the output if the output of both these gates are high, then only the output of the total output will be high, otherwise output is 0. That is, if this is 0, this is 1, the output is 0, or if this is 1 and this is 0, output is 0, or both the output of gates are 0. For all these cases the outputs are 0, right? And that is same case for the output of XOR and NOT. Okay, now the question is the number of distinct values of x3, x2, x1, x0, that is out of the 16 possible values that give y equal to 1 is. So we need to find out of the 16 combinations of x3, x2, x1, x0, for what all number of these values the output y will be equal to 1. Say the output of this XOR and NOT, we'll call the output as A, and here the input of this AND is x0. So output of this AND gate I will call it as B. Okay, and here it is input is x0, so here it is x0 bar. Okay, and here input is x3, so this is x3. Okay, and let the input of this OR gate be I0 and this be I1. So here, so the output of AND B is given as x0 into A, right? x0 and A. Fine. So we'll see the different values of B when for different values of x0. So if you see x0, when x0 is equal to 0, what happens to B? B will be equal to 0 dot A, that is 0. Okay, and when x0 is equal to 1, then B is equal to 1 dot A, which is equal to A. Fine. So this is the value of B. Now what happens here? There is one more input connected together, that is x0 bar. So if x0 equal to 0, what is x0 bar? x0 bar is equal to 1, and when x0 is equal to 1, then x0 bar is equal to 0, right? Now if you carefully see this I0, right, I0 actually depends on is function of both x0 bar and b, right, because this b and x0 bar is connected together. So if any one of these inputs is 0, the output will be 0, and if both are 1, then the output is 1, right? So if you take the first case, that is when x0 equal to 0, the output or b is 0 and x0 bar is 1, which means for this case I0 is equal to 0 because 1 is 0, right? And similarly for case when x0 equal to 1, the output is actually corresponding to I0 equal to again 0. Why? Because b is a, that is it can be 1 or 0, while x0 bar is 0, so definitely I0 will be equal to 0, which means for any case of x0, the value of I0 is 0, right? So I0 is actually always 0. So what is y? So what is this y? Y can be written as 0 or I1. Okay, this is I1. So where I1 is actually x3. This is 0 plus x3 or x3. So y is actually x3 itself. Okay, so when x3 is 1, y is 1, right? When x3 equal to 1, y is 1, and x3 equal to 0, which means y is 0. Right, now the question is for what number of values of this x3, x2, x1, x0, y is 1. So which means y is 1 for all values of x3 equal to 1. Right, so how many values will be there? So we know we have x3, x2, x1, x0. Right, so any value of, we don't care what is value of x2, x1, x0. If x3 is 1, then y is equal to 1, and when x3 is 0, for any values of this, the y is 0, right? So here how many number of such terms will be there? So how many combination of x2, x1 and x0, right? So which means we have 8 number of such combination where x3 is 1, right? So for 8 number of distinct values of x3, x2, x1, x0, we have y equal to 1. So 8 is the answer.